It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, in this lesson we're going to be talking about the end behavior of polynomial functions. So yesterday we spent time graphing polynomials, and today we're going to talk about their end behavior, which we don't care what happens in the middle. I want to know what happens at the end as I go to positive infinity and negative infinity. What's happening to my graph? So let's start with this opening exercise here. A degree 4 polynomial with a leading coefficient of 1 is graphed below. Write an equation for this polynomial in factored form. So if I want to know about my factors, I need my zeros. So if I look at the graph here, I've got 1, 2, 3 zeros. X equals 1, x equals negative 1, and x equals negative 2. So that tells me my factors are x plus 2, x plus 1, and x minus 1. But notice it's a degree 4 polynomial, which tells me I should have 4 factors. And at the graph here, notice that x equals 2, the polynomial touches it and then turns around. So this tells me this is a repeated 0 here. So that tells me I have another one of those factors. That factor there, if it ever loads again, there we go. Come on, you can load. That factor there needs to be squared. That factor of, there we go, that factor of x plus 2 needs to be squared. So that there is my polynomial. So today we're not focusing on the zeros. Today we're going to be talking about the kind of the arrows on my polynomial, of where are they going? What's the end behavior of these graphs? So the graphs of 3 polynomial functions are shown below. Describe similarities of the graphs and equations of these functions. So the first thing I notice when I look at all of these graphs here, both of the arrows are pointing up. Both ends of the polynomial are skyrocketing up to positive infinity. So the arrows are both pointing up, and if I look at the equations, the degree of these, x squared, x to the 4th, x to the 6th, is always even. The degree of these, that highest power, is always even, and the leading coefficient, the number in front of that, so 1, 2, and 1/2, is positive. So that creates a polynomial where both ends are skyrocketing up to infinity. So what we say here, when I describe the end behavior, as x gets really big, as I go to the right of my graph, where's my function going? In this case, it's going up. My y values approach infinity. So as x gets really big, my y values are also getting really big. As I go to the left, as x goes to negative infinity, so the other side, if I go to the left of the graph, where's my function going? In this case, the y values are also skyrocketing up to infinity. So this right here is how we describe end behavior. As x gets really big, what's happening to y? As x gets really negative, what's happening to y? And it depends on 2 things, the degree and the leading coefficient. So even degree, positive, has that up. My right hand's going up and my left hand is going up. The graphs of these 3 polynomials are shown below. Describe similarities between the graphs and equations. So hopefully you notice the end behavior of all of these is the same. They're both skyrocketing down. Why are they skyrocketing down? Well, it has to deal with the degree and the leading coefficient. The degree appears to be even again, 2, 4, 6. The degree is even, but this time all my leading coefficients are negative. All my leading coefficients are negative. So as x gets really big, as I go to the right, my right hand, the right hand of this polynomial is going down to negative infinity. It's plummeting down. And as x gets really negative, as x approaches negative infinity, where's my left hand going on my polynomial? Those y values are also plummeting down. So the only thing that changes is right here. This setup is the same every time.
Thank you.
No problem. So that's how we describe the end behavior of these polynomials, is as x gets really big and as x gets really negative, that's what we look for. Describe this, so let's practice this. Describe the end behavior of this polynomial function. So to look at end behavior, we need two things. We need the degree and the leading coefficient. The degree is even, and my leading coefficient is positive. So as x gets really big, where's my y value going? As x gets really negative, where's my y value going? Well, if I'm even degree, that means they're going the same direction. Even positive is going up in both directions. Even positive, I don't know what happens in the middle of this graph, but I know that's how it ends. They're both going up to positive infinity. So that right there is my end behavior. Describe the end behavior of this polynomial. Is the leading coefficient positive or negative? So the end behavior, we're describing those arrows. The end behavior, they're both going down. So as x gets really big, my right hand, my y values are getting negative. And as x gets really negative, my left hand, my y values are still getting negative. So since they're both going down, that tells me I have an even degree. My degree is even, x squared, x to the fourth, x to the sixth. But my leading coefficient is negative since they're both going down. So I have an even degree with a negative leading coefficient. I have no idea what the equation is, but I can kind of describe that first term for you. I don't know anything about the zeros or any of that stuff. I know what's happening at the end behavior. All right. The graphs of three polynomials are shown below. Describe the similarities and the differences here. So notice this time the end behaviors are different. Starts low, ends high. Starts low, ends high. Starts low, and I don't know what happened to the rest of this graph, but it ends high like that. So let's describe the end behavior. Where's my right hand going? As x gets really big, my right hand, the graph is skyrocketing up. As x gets really negative, my left hand, where's my graph going? Well, all these graphs are plummeting down. So what's causing this to happen? Well, we look at that leading term there. The degree is odd while I have what type of leading coefficient? Positive. So a positive leading coefficient and an odd degree make this kind of snake where I start down low, end high. Start low, end high. As x gets big, y gets big. As x gets negative, y gets negative. Same thing again, but notice the end behavior finally changed for the final time. This is it. This is all the end behaviors that we got. So notice these start high and end low. I don't know what happens in the middle, but I know it starts high and ends low. So as x gets really big, as x approaches infinity, where my right hand, that's my right hand there, my y values are plummeting down to negative infinity. And as x goes to the left, the negative way, my y values are approaching positive infinity. What's causing this to happen? Well, notice that they're both not going the same way. That's coming from the odd degree. I have an odd degree, and every leading coefficient here, every leading coefficient is negative. Every leading coefficient is negative. So it just takes time to kind of understand how these polynomials work. If I have an even power, my end behavior is going the same way. The leading coefficient decides if they both go up or they both go down. An odd power starts low, ends high, but if I have a negative leading coefficient, it starts high and ends low. So it just takes time to kind of practice getting used to this. And here's kind of a little chart for you to look at. Even degree, positive, negative, odd degree, positive, negative. And here's kind of the symbols for you to reference back to. Notice they all start the same way. This doesn't change. The only thing that changes is where are they going? Where's my left hand going? Where's my right hand going? Or this is your right, positive infinity is your right hand, negative infinity is your left hand for these x's here. All right, so we'll talk about this more in person, but I just wanted to show you that we have this little chart here. So let's do this last problem and we'll call it a video. So let p of x equal this lovely polynomial here. And I asked you what is the degree and the leading coefficient. So the degree is how many factors. If I was to multiply this all out, what would x to the highest power be? Well, I have 1, 2, 3. So I have 1, 2, 5, and 3 factors there. So if I was to multiply all those factors together, that gives me a degree of 11. So my degree is 11 because I have 11 x's here. I have 11 different linear factors there. And my leading coefficient is that number out front is -3. So I have an odd degree with a negative leading coefficient. So describe the end behavior. Well, which one's this? Odd degree, negative starts high, ends low. So as x gets big, my right hand is going down. As x gets negative, my left hand is going up. So the odd degrees go in the opposite directions. You just have to know which way they start. Negative leading coefficients start high and end low. So state the zeros. So the zeros come right from my factors. So if I know my factors, I know my zeros. Okay. So I know my zeros here are x equals -1, x equals 2, x equals -4, and x equals 7. And their multiplicities is how many of them do I have? So I have one of these guys, I have two of those guys, I have 5 of those, and 3 of those. Why does that matter? Because that tells me if I cross through or turn around. Cross through, 2 of them is going to make me turn around. Cross through and cross through. It's the even multiplicities that tell me to cross through or turn around. So using that information, I can now make a sketch. I can now make a sketch because I have zeros where? And zeros at -1, 2, -4, and then 7. So those are my zeros. I know I start high and end low. So I get to -4 and I cross through. I get to -1 and I cross through. I get to 2 and I turn around. And then 7, I cross right through. So using all this information, we can quickly sketch graphs of these polynomials. I have no idea how high or how low they go, but I do know the end behavior and the zeros. So when we sketch polynomials, we use their end behavior and their zeros to make our sketches. See you guys in the next video or in class. I don't know, whenever I see you again.